This section has nothing to do with GNSS and nothing to do with surveying. Watch it if you want to have little fun in getting to know the charge-discharge behaviors of batteries. In Triumph BS, we give detailed information about the behavior of battery packs and the charging system. Click the battery icon on top right of the screen. Battery screen appears. There are two independent battery packs within the removable battery pack of Triumph BS. They are charged and used independently, and each have their own 3-pin connectors in the bottom of the battery pack. In the battery screen, the two boxes on the top left show temperature in the left and the right battery sets. The next two boxes show temperatures in the GNSS section and in the communication section of Triumph BS. In the next box, you see the voltage of the external supply, if external supply is connected. Next box is the internal voltage. This is the voltage prepared by the Triumph BS power module and delivered to all other modules. The next two boxes show voltages of the left and the right batteries. And the last two boxes on the right side show charging currents for the charging the two battery sets when external power is connected. At this moment, the charge current is 0 because batteries are fully charged and do not need any charge current. The graph in this screen shows the 15-hour charge-discharge history of the batteries. Black color shows the internal voltage graph. Greens show the battery voltages, and blue graph is the charge currents. This graph has three distinct sections. The left section is when external supply was applied for a long time and battery was fully charged. The graph of the internal voltage in black color is constantly at 9 volts. The internal voltage was prepared based on the external supply. The two green lines show the fully charged voltages of the two batteries, which are about 8.4 volts. The charge current graph in blue color shows value of 0 because batteries were fully charged and did not need any charge current. All energies were supplied by the external power. The next section is when external power got disconnected. It shows a total discharge cycle where batteries were supplying energy to Triumph BS. In here also charge currents were 0 because there was no external power connected to provide charging currents. The internal voltage is the same as battery voltages, and it dropped the same as battery voltages because now batteries supply the internal voltage. After 7.5 hours of continuous work with maximum load, the batteries got fully discharged. Note the very sharp voltage drops in the last 15 minutes of this cycle. Prior to this sharp drop, the voltages are relatively flat in some areas. That is why it is hard to estimate the remaining battery time just by looking at voltages. You can look at the discharge shape and decide where you are in the graph and how much time is left. The last segment is when battery was fully discharged and external power applied. Again, internal voltage, the black line, is fed by the external source and it is sitting fixed at about 9 volts. Battery voltages rapidly rise to about 7.5 volts and then gradually reaches full charge of 8.4 volts. For batteries to get fully charged, the smart charging system provides about 1.5 ampere constantly until batteries are almost charged. Then charge current gradually decreases to 0. When the battery is fully charged, the charge current is cut off. This charging profile is designed according to the characteristics of the lithium-ion batteries to preserve their chemical structure and their lifetime. There are 2 LEDs in front right side of Triumph VS, which show the summary status of batteries depending on where we are in this graph. The top LED shows the energy left in the batteries, and the bottom LED shows the charging status when external power is connected. Discharge takes between 7 to 9 hours depending on which modules of Triumph VS are turned on. Complete charging takes about 3 hours. When external power is connected, the color of the green on top LED means battery is over 90% charged and the charge current is less than 1.4 ampere. And we are in this region of the graph. Yellow means voltage is about 7.5 volt and we are in this region of the graph. And red means voltage is below 7.5 volt and we are in this region of the graph. When external power is not connected, the color of the green on top LED means battery voltage is about 7.5 volts and we are in this region of the graph. Yellow means it is between 6.5 and 7.5 volts and we are in this region of the graph. Red means it is between 6.25 and 6.5 volts and we are in this region of the graph. Blinking red means it is below 6.25 and we have about 2 minutes of battery energy left. The bottom LED shows the charging status when external power is connected. Red means battery is not charged and the charge current is above 1.4 amp and we are in this region of the graph. Yellow means battery is partially charged and the charge current is between 0.1 and 1.4 amp and we are in this region of the graph. Green means batteries are fully charged and no charging in progress and we are in this region of the graph. Note that both batteries always have similar graphs and almost fall on top of each other. If you see their graphs are far apart, it means you need to clean the battery contacts or the battery pack is faulty. To be complete on the issue of LEDs, let me also explain the LED in front left of the Triumph VS. It is for troubleshooting. Green means all okay. Blinking green means connection with GNSS board is lost. Blinking yellow means connection with communication section is lost. And blinking red means communication with display and user interface section is lost. These troubleshooting colors and LED is not applicable when a unit is being reloaded and installing new software.